Hello everyone. I think it's some time. Thanks for holding up until now. I appreciate it. I think we had a very good food, right? But we're just putting there. I see. Just hold it for next 90 minutes, that's it. Right? So why I'm here? Anyone had a chance to look into the agenda, what he is or spoken about? Any ideas? You know? Any ideas?
Serverless for Elastic now.
Serverless ka?
Elastic now.
Okay. ठीक है. Okay. I think he's all fine. So that's what I'm going to talk about. So I'm just going to talk about building Elastic Cloud Serverless on Kubernetes. So in short, how we build a multi-cloud, multi-region Kubernetes cluster using Kubernetes controllers. And we are able to support more than 67,000 containers, scaling, storage, and all those things that I'm going to cover. And why I'm talking about it? So to give you a quick introduction, I'm Someshwaran known to my widely known as so in meetups and groups. So what I do is I do developer advocacy for Elastic, and I call myself as an open source enthusiast. So I've been working in open source for a while. Luckily, I got into Elasticsearch as well. How many of them know ELK? Thank. That's a good number. Okay. So if someone don't know ELK, so basically we'll be having like ETL pipelines, and you can have Logstash and send it to Elastic and use Kibana to visualize it. So that's what we're doing in very much in short. I'll take you through one by one. And basically what I want to do, or why I'm talking about serverless now, is we started the serverless journey back in November 2022. This is more of a backstory of how we built serverless, because we have been known for building stateful sets of billiard statement clusters, and been to moving ourselves away from stateful to stateless, as well as from completely to a serverless system. It was a huge challenge, and that's what we started back in November 2022, and we went GA in 2025, as you see, December, into solid 2 years with all the discussions and what we have come up with all those challenges. That is what you're going to see in next 15 minutes. And the idea here is, I know this is an afternoon session, right? So we want to make sure as much as possible how we can make it much more interactive. I will leave it up to you guys, right? The promise that I can make is whatever I'm going to talk today, I'm not sure, Gagan, that you will be able to understand, or maybe it might feel overall to someone. But what I want to, probably you can take this away, maybe with some curiosity of this session, is how can Elastic can do this, maybe how we can do this. That would be the idea. How you guys can adopt the same design patterns and technologies that we have been using it, and how we can pick those design patterns from the Kubernetes, maybe orchestration itself. To give you a brief, maybe let's understand who is here. Maybe quick show of hands. SREs and platform engineers working with K8s. SREs. Okay. And DevOps, DevSecOps, FinOps, DevFinOps, quite a lot of 90%, 80%. And cloud architects, infradecks, who are building infrastructures. And thank you. And students hearing Kubernetes for the first time. Hear Kubernetes for the first time. Oh, thank you for coming. I'll make it much more easier. The idea here is to keep things like make sure you're able to take away what we are handling. To start well, I know you have already answered this question. You guys have already known about Elastic, heard about it, and working on it. Maybe I'll quickly run through a few things where what is Elastic and what we are doing in terms of search, as well as in terms of serverless. So Elastic is built on top of Apache Lucy. Anyone worked on Apache Lucy? Okay. Apache Lucy. So basically, Elastic is more of a wrapper on top of Elastic Apache Lucene, and how we manage is basically through shards and segments, as well as all the persistence, right? And you can do, it's more of a search and analytical platform. You can do like keyword search and Any search engineers? And search engineers, AI, ML engineers. So in case if you are working on search, RAG, everything, Elastic Search is a better vector to be in that case. And if you are not sure who are using it, so you give an example using GitHub usually for the search, basically whatever repos you are searching is on in GitHub. So basically Elastic is the backend system that is supporting on the search. And if you have not used GitHub by any chance, if you have used PhonePe and you see all the observable systems that on PhonePe that runs on Elastic, there's a very nice blog that they have written in terms of scale, how they were to scale Elastic, all the auto scaling and everything. Feel free to have a check when you have time. And just a quick brief. So close legend marketing deck, but trust me, I'm completely coming from engineering background, so I'm just going to talk much more information. So Elastic has these three solutions: this is search, observability, as well as security. So if you see in the stack, the Kibana, Elasticsearch, and Beats, as I said, Beats are something that basically they lock ship. They keep from your source, send it to Elasticsearch. And Elastic is more of back-ready, like I said, go tarnish Apache Glycerin in this is mission segments. And then you can run, can you see one and two query? That's it. And what we had before, so we all know Kubernetes, right? Don't know, we can know Kubernetes. But before Kubernetes, we were trying to build an orchestration platform for us to support, right? 10 years back, what we were trying to do is basically called as ECV, where we were easily able to run around 600 containers, 600,000 containers, right? And it looks like this. You might feel this is more of it looks more of an Kubernetes itself, right? But this is all the basic building blocks that we require to build Kubernetes. The proxy to proxy, control plane, and Zookeeper for HC. Let's say you want to do state management and everything. That's what Zookeeper and Constructor does. Mainly, and we have Cloud UI and the API server and all this. And this is more of a just what we have in these. But I'm not talking about this today. Basically, we had one more, which is ECK. Still, as you saw, it's a big state reason, right? It's a big state reason, whatever you saw. And whatever with Kubernetes as well, we created an operator where operator does all the CRVs and then it builds all the schedule sets. That's all, right? And that's something that we were doing. But what we want to do, what maybe where we want to move is basically you want to move from the Kubernetes, from the equal sets to something like Stateful. And this is where we started working on shared nothing stateful architecture, which is the old one that we had. As you can see here, this looks like all the EC2 instances. For example, I'm just giving you an example. These are kind of in EC2 instances. Okay, but just picturize it where, let's say, it has the disk as well as it has its own JB where is memory, and it has its own CPU or the compute, and all these are kind of a monolith, right? The kind of an instance that comes along with it. It has its own disk. And these are nodes. We call these are nodes. This is the previous architecture which I call as stateful, right? But if you see here, the same thing, node 1, node 2, node 3, and we have the primary shards, replica shards. Anyone working on shards before? Shards, the texting VV, any VVs? Exactly. So it has this primary shards and it has its own losing segments. From losing segment, it has its own branch laws and everything. So we have these indexes in the shared in our previous stateful architecture. This is where the challenge. Basically, we want to move away from this. We want to move away from the stateful set where we have primary shards and replica shards, and then if we have one host search, we have to increase our disk or maybe increase our compute. And if we have more indexing, if you need more storage, then we have to, it's about tighter, right? Whatever you see, it's all tighter, right? But in case if I have a high decision, right? Or maybe high search, I don't need, like maybe I have to trade off my ingest also. But that is where we want to remove ingestion. So if you see, one fine day we decided, okay, let's move to stateful to stateless, right? Would that be motivation behind it? But no, but we have a motivation behind it, stateless essentially. And basically this is the motivation. So it was it was more of a learning curve from the customer as well. Like I showed the instances, right? It's very easy to see, but during those instances, what's the instance size that you wanted? It's more of a customer heavy lifting, right? It has its own CPU, RAM, tied to this storage, And then this side, you see it has source ingestion and ingesting as well as the searching, which is more of what the stateful says, right? And this is where we were trying to move from goal one, how we can scale more containers, is to decouple the storage as well as compute from storage as well as the storage one. That is what we were trying to do. This was the previous architecture where I said you saw hot tires, you saw cold tires, and data movements from hot tire to cold tire and all those. These are managed by the customers of the users. But what we tried right hum, we just put everything and let's make indexing tire separately and let's make the search tires. In this way, we may in only one source of truth, which will be the blob store. So everything moving from indexing, it will go to the blob store, and the search timer will automatically fetch it from the download it from the blob store, and so the users on the other side. And like I said, the compute and storage is separated. Now we are trying to do this, but this is the new scaleless architecture where what happened in the blob store is we had all those indices in the blob store, and we have translogs pushed to the blob store. So from the indexing column, right, we were able to scale more nodes. In case indexing is heavy, we can scale it to three to four nodes. As well as on the search side, you can have much more nodes, right? It depends on what you would actually require and use cases. So like you see saying the indexing, losing segments and transblocks, and these does not actually get stored in the disk of the nodes, is basically just for the cache layers. This loads for some time, and then once occur, it creates a commit, it sends this to the blob store after some time. So what we were doing once we got into this stateless, right, we were trying to understand how Lucene works, right? That's when we were able to make much more impact on performance and face connectivity. Let's see how, like I asked, anyone worked on Lucene? I think go hands are. So yeah, thank you. Just one hand I feel. So now that experience 2016 exact. So maybe I just give you a brief of how Lucene works so that you will know how Elastic works or no. So when you ingest the data to Elasticsearch, right, what usually happens, create something called as shards for indices. The indices has documents, it creates documents. And it is actually the shards. Play is one index, where is one primary shard as well as the replica shard that is created, which is the redundancy vector. And these shards do live in something called as in-memory buffer. So immediately when you send to the shards to, let's say, the documents or ingestion, it will not get stored in the disk. It will usually get stored in in-memory buffer. So once you store in the in-memory buffer, after a refresh is something that you make, then you send something new data. Once you refresh that, that's when it can be searchable by the clients or the users on the other side. So once you do the refresh, this in-memory buffer, whatever it's there, the documents, that gets pushed as the losing segments. Losing segments are files, basic files, which works on, let's say, then we see format, and then it tries to understand what are the data that you're interested in. And once it sends the losing segments, you can move on, do a flush. When you do a flush, basically flush and nothing but you take all data, push it to the disk. So then that will become first extractor. That is the actual process of how losing is integrated with Elastic and how losing works also. There are two things that you need to keep in mind. One is losing segments, the other one is refresh. So once we started doing this, right? So you see, this is the first ocean. First ocean is like very simple, right? I had the refresh, and it's like I had that segments coming in. I send it to the index node. Index node is the ingestion tier. Once I have the ingestion tier, I can upload it to the, let's say they have a log line. I can just upload that log line as a blob to the blob store. Okay, consider this in S3 for 3. Okay. So, and then, like I said, search can just take it from the blob store, and in case it can serve the users. Very easy, right? Much easier, right? Where what happens is like our put request to the blob store and got exploded. Basically, as you have S3 or let's say gets exploded, what happens? The cost lows on the farm. Then one point in time, our cost of S3 or the put request is much more than the hardware itself. So there is no point in probably sending it to the block store at that point in time. So what we did in additional, we created a separate data structure himself to how to handle it. So in terms of low-level design, how we are working, like I said, the same thing remains. You send a refresh, basically you send the data to the ingestion node, but we don't immediately send that segment. Once you have that segment files, right? You don't immediately send it to the blob store. What happens is we wait, and what we do is we create something called as bash confound commit. So these files, dosing files, are added to basically just is a merging couple of files and making sure we have a good 16 MB file, or maybe based on your tuning parameters, and then we should be able to push it to the blob store. And until then, we will wait. And what we'll have is we'll have trans logs. So basically, what shard or what documents that is actually more of a cluster state maintenance. So when you have that maintenance, we will show that in the blob store. The reason why we do it is to make sure the search store knows what exactly this is happening, what exactly the index that is happening on the refresh index no less. So after some time, what you see here is basically all the bashed segments into one in a one segment, which is a batched compound commit, and this is more searchable also. If it's not uploaded to the blob store, search node will know, okay, this is not available in the blob store, but let's check in the index node. In this index node, it is searchable, saying that, okay, is this available or not available? Because this lives in the cache of the index node. So after some time, let's say there's a refresh and then we are trying to push the commit, it gets available in the blob store. So this is the difference which we made, which reduced the put request directly to the S3 and completely gave us a new way of handling how we can push put request as well as creating the bash compound commit. So goal 2, as you saw, goal 1 is completely based on whether it will work or it will not, right? We try to decouple two things, whether it works or not works. I just want to make sure, can I go ahead with this project of some rollers, or can I? Once we had this in mind, right? Once we were able to solve it, then the second thing, like I said, we were able to do 600 containers in EC, which is a orchestration built on our side, right? So whether we were thinking whether we should adopt Kubernetes and the stateless, right, shardless architecture, or if we go with EC itself. But we had very simple concepts in mind, right? If we want to extend Kubernetes or adopt Kubernetes or extend EC or adopt Kubernetes, very straightforward. One is we found rapid Kubernetes adoption is there, right? And people are trying to contribute much on the Kubernetes side, and we have a strong CSP cloud service providers from the Kubernetes side. And we have standardized APIs already in Kubernetes. And that is one of the advantages that we don't have to build it from scratch. And also we know how to reinvent it again. As I said, when I want to extend it, we don't want to do it. And we had a time crunch. So based on the time constraints, we want to make sure we deliver serverless at the better scale as well as with respect to the performance. And that is something we felt. And then we went and chose, okay, so we chose Kubernetes. But what other problems that we had was, okay, we chose Kubernetes now. Now again, the blueprint written problem. Is it CSP managed or CSP self-managed? So can you guys tell me, being Elastic this, right, building these systems for a while, we felt like, okay, we can do everything on ourselves. We don't have to care, right? Do you think what we would choose new problem after this situation? Anyone? Is CSP managed or self-managed? Self-managed, right? Even I was thinking the same thing, right? But that doesn't happen. So basically what happened, due to the constraints and due to the adoption of Kubernetes as well as we want to make sure it is much easier, we went with the CSPs itself, the CSP managed one, and using, again, there is other program. CSP have their own K8s implementation. And what we got help from is basically Crossplane. Anyone use Crossplane here? Crossplane, Google Anthos, Terraforms. Yeah, exactly. So at that scale, we were not able to use Terraform because it was failing and we were testing it out. And Google Anthos came close to Crossplane. Google Anthos was much gooder, but the cost of ownership of Google Anthos was much higher than what we had as Crossplane. Crossplane do had some limitations, but it was much more, we should be able to handle the limitations based on scale of windings and overseeing, but it was still under control of the Taiwan infra, so where they can issue the. So we went ahead with the Crossplane, where as a loan Kubernetes API is already, you don't have to build everything, and can do the CREs. And we really depend on custom controllers because we do custom controllers and we make sure how we can use within our limits using the Kubernetes pattern. So that is when we felt, okay, Crossplane would be a much bigger toolkit for us to probably work on it. And this is how it looks. The architecture for now where the Crossplane is the operator layer, you just send some serialities and it will deploy it based on different AWS or GCP or Azure because they have their own, let's say, the proxy and the way how they want to probably handle the API implementations. They have their own API implementation. So we made it much more unified for us. In this way, Crossplane was playing a bigger. And goal 3 was networking. So we had the CNI. What would be the CNI and how we want to focus. So these are the requirements. So replace default queue proxy, deny all by default, finding the range across egress control and blob CSP metadata. And it should have rich observability and eBPF and everything. What do you think would be the right solution they would look at? Anyone have removed queue proxy from your end? From your CI? Anyone? Why do you remove it? Latency. Okay. And anyone know L7 layer? Why how it burns from seeing or to proxy? Does it have the capability to do it? Okay, so I'll go straight to this. So basically, we started using Cilium and it worked across all 3 platforms, EKS, AWS or GKE, right? And it was much easier for us to work with C. And it has its own limitation with respect to cloud providers, but we were able to purely self-manage, remove completely from Go proxy, and then deploy it in AWS much easier. But on the other platform, it was a bit of challenging, but still it was possible. With data plane V2, and it was easy for us to model it by Cilium for higher visibility. Like I said, the focus was to get more visibility using eBPF, understanding egress, working all those L7 layers policies, everything was possible in respect to Cilium. So this was the solution that we were able to probably make use of, change the container networking interface, which has much more ready for us. And goal 4 is basically very straightforward. We have an architecture in SVNs. And what is the basic or what is Kubernetes uses? What's the push or pull model does it? Kubernetes using? So push or pull. So what does Kubernetes using? Push or pull? Anyone? Which model? Cool. Exactly. But what we want to go is we want to go with the hybrid method where we want to go with push mod. So it's basically we want to instruct basically with respect to the Kubernetes and making sure that we send out the information to those Kubernetes clusters so that it does not wait for our, in case there is any control plane failure, data plane is still working and without any further. So this was one of the key competitors, key reason why you want to push mod. And like I said, cloud capacity, did anyone has said insufficient cloud capacity? Anyone not felt about? Okay, so basically what happens when you have cloud capacity issue? The CFT asks us to just wait there, right? Whereby we find some solution and get more space, right? And that is what our thing. So we figured out how we can do an auto scaling, do a custom scaling out of it. Kubernetes has this design here. Basically, it's like after 300,000 containers cannot scale with respect to the Kubernetes cluster. But this is where we have to use something called as priority-based capacity pools and proactive capacity planning. How we do this is basically using recommenders and mappers and stabilizers. So they continuously take the metrics from ingestion as well as the search query. And based on that metrics, they understand, okay, should be auto scale or probably down scale. And then they keep the mappers to, okay, use this more for patching, right? You update your limits and based on that limits, the CPU when completed support. And finally, the 2024 December, we had that serverless GN, which went live. And what we feel, and basically how we are able to probably move all these containers, we feel what by the end of the day, we felt like we were able to build something of engineering marvel with what we have done with all this scale as well as how we are couple and everything. What I've shown is very high level architecture or high level discussion of what we did on 5 parameters, but there are more in how we have designed. And what you can do is you can take a photo of the logs that I'm going to share. This is something if you want to understand more on stateless and serverless, feel free to take a look at just 24 English. So you can listen.